All right, so I'm gonna walk through how to do this quiz is assignment. It does add another layer of the regression because not all of these problems are gonna be the U shape. Some of them are gonna be lines. And so I'm gonna show you how you can easily do this in Desmos, comparing and getting the right answer. There are 19 questions, so it's gonna take you a bit of work. But you got an entire class period. You should be able to finish this in like 45 minutes max and still have half the class to chill. So I'm just going to go through the actual questions. This is the first one. It says table shows a relation between number of hours and total price. And they give us this. So if we notice, all of the answer choices just have a single letter. There's no squared letter. And so this should look like mx plus b, y equals mx plus b, which is a line, which is linear. And so last class we focused all on quadratic, but today we're going to do both. So we're also going to set up y1 in the same way, but instead of the approximately ax squared plus bx plus c, we're going to do mx plus b because this is a line. So mx, we still have to say x1 plus b. So this is the generic line, y equals mx plus b, but we're using y1 and x1 because when I go to add an item, add table, I'm going to make sure that this says x1 and y1. You can see that mine does not. So I need to go and make sure this says x1 and y1. And now I can just plug these values in right here. So this is going to be 4, 6, 8, 10. And for my y values, we got 43, 63, 83, and 103. So if you hit the magnifying glass, zoom fit, it will show you the scatter plot, which is the green dots. And you can see that a line is going to go perfectly through these dots. So the blue line is going through the green dots. And that's how we know it's correct. This equation is going to have a m value, which is slope of 10, and a b value, which is my y-intercept of 3. So from 0, 3 is going up 10 and over 1. So if I looked at 1, it has gone up 10 and over 1 from 0, 3 to 1, 3. That's where the m is coming to play. But all we care about is these values right here, m and b. So my function, f of x, is going to be m, which is 10, x, plus my b value, which is 3. So this will be the answer. Remember that if you're trying to type something in to evaluate, you could just do mx plus b. And that will also put this line up there. So you can just keep it generic once you set this up. Just keep it generically as mx plus b, but this is the equation. And the reason we would do the generic one is so that if I wanted to figure out, okay, well, what is the price going to be for 11 hours of babysitting? You just make sure you have this one up here, and it'll plug it in for you. So it would be 113 if it asked for 11. So mx plus b, m is 10, b is 3. That is the last option. All right. This is my recommendation. Get 2 Desmos. Virginia Desmos graphing calculator. You have to be able to do this with the green label one, not the black label one. On problems that work with a curve or a quadratic, I would have one set up with mx plus b, and I would have another tab set up with the quadratic one. So approximately, this is what we did last class, ax1 squared plus bx1 plus c. So I'll have one setup where it's the linear with mx plus b, and the other setup with quadratic where it's ax squared plus bx plus c. Remember, these all have to have a 1 on them, and then when I make the table, make sure that this is also x1 and y1, not a 2. So this is 4, 8, 11, 13, 15, and 6, 44, 92, 132, and 183. I really need some glasses. Okay, and we can click the magnifying glass, zoom fit, and we see that the curve goes through these perfectly. That's great. Where this is going to be my A and B and C. So since this one's a bit messy, I don't really want to type y equals 0.952 x squared minus 2.079 x minus 0.747. This is a lot to type. So instead of doing f of x like this, if you just type f of x equals, just use a and b and c in front of your value. So ax squared plus bx plus c, and it'll just do it for you. So if you want the equation, sure, there it is, but it's going to be easier to work with if you just use the generic a, b, and c. And so there it is, 0.952, negative 2 point, yeah, it's this one, the second one. All right, so we'll have one tab for linear and one tab for quadratic, and then you can switch back and forth. But the problem is some of them we don't know. So these are going to be the challenging problems. Like I don't know if this is a linear or if it's a quadratic, so I would even recommend getting a third one, Desmos, Virginia graphing, and checking. I mean, you can just guess, and you got a 50-50 chance. But it's probably better if we just do it in a separate one. So if I type these in on a third one, we got negative 2, 0, 3, 4, 6, and then 18, 7, 16, 25, 60. I don't know if this is linear or quadratic, so I need to hit the magnifying glass, zoom fit, and look at it. And to me, this one is going down and then it's going up. So it looks like there's going to be a U in this shape right here. And a U is quadratic. So I will take this. I wish there was a way to copy and paste, but I don't think that there is. I want to use the quadratic one with the ax squared plus bx plus c, and I'll type it into this one. So negative 2, 0, 3, 16, 4, 6, 18, 7, 16, 25, 60. All right, and since I already had this one set up, it's going through the quadratic. It says, given the set of data, estimate what the value of y will be when x is 14. So if you set this up with the generic one, f of x equals ax squared plus bx plus c, you can just type f of 14, and it will just find the answer for you. So 342.7. I guess they were rounding. So if we were to round this thing, they must have rounded with these numbers right here, 1.894 or 1.895 squared minus 2.469 plus 6.003. They must have done a bad job rounding. Maybe they just did this as 0.9. Yeah. Yeah, they just rounded to one decimal place. But either way, just pick the one that's closest. It would be this one. So I hope that that's helpful. I would have three tabs open, one for linear, one for quadratic, and then one to check and see is it a curve or is it a line. So good luck, and I'll see you next week.